Alright guys, we have question 36 in this video, and we have a surveyor that sights a target at C from points A and B, recording the angles that we can see 42.5 and 63.8. And the question is asking us to determine the magnitudes of the position vectors A and B. So we're going to use trigonometry to solve this question, and first of all, we're going to do the law of sines in the triangle that I'm highlighting in yellow. So we have this triangle where we have one of the angles 42.5. We can find this angle that's going to be 180 minus 63.8, which is going to be 180 minus 63.8. That angle is going to be 116.2 degrees. And since we have a triangle, this will be 180 minus the other two angles. So this plus 42.5 is going to be 158. So this angle would be 180 minus the sum of the other two, 158.7. Let's see what we get. And that's going to be 21.3 degrees. Now that we have this, we just have to use the law of sine. So basically we have the sine of 21.5.3 degrees over the side that is facing that, which is the 200 meters. We have sine of 116.2 over A. And from here we can just cross multiply this and find A. So A would be 200 sine of 116.2 degrees divided by sine of, so let's just figure out A first. So 200 times sine of 116.2 divided by sine of 21.3 degrees. So A would be 494.02 meters. And we know here this is also equal to sine of the last angle, 42.5 degrees over the side that is facing B. So now we can cross multiply these two. Our B will be 200 sine of 42.5 degrees divided by sine of 21.3 degrees. Let's calculate this one too. 200 times sine of 42.5 divided by sine of 21.3, 371.97 meters. And yeah, that's going to be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.